All right, chapter 3 is getting into our basically our linear equations. And we're going to start by looking at what we call recursive sequences. So recursion or recursive sequences is basically an ordered list of numbers defined by a starting value and a rule. And I bet a lot of you have seen a bunch of recursive sequences. So an example would be like 3, 7, 11, 15. Well, right? And it just keeps going. So what's happening here? It's really adding by 4 each time. And in this case, it's starting with the number 3. So I would say its starting value is 3, and its rule is plus 4. Okay, and the same could work for multiplication. I could have something like 2, negative 4, 8, negative 16. Well, what's happening here? Our starting value is 2, and what would our rule be? Well, it's multiplying by negative 2 each time. And what's the easiest way to figure things out like that? Well, if it's being added or subtracted, I can just take one of the terms and subtract by the previous term. So 7 minus 3. So I know it's a positive 4 each time. If it's being multiplied, I could take one of the terms and divide by the previous term. And that would give me what it's being multiplied by each time. Well, so for my rule over here, I shouldn't just put negative 2. I should really put times negative 2, right? So I put my dot for times, or I could, say write the word times negative 2 just so we know. So first thing, it says find the missing values. Well, I have to decide, is it being added by something or subtracted by something or multiplied? Well, just find some terms that are kind of by each other. So here it went up 5, right? Because I could take 12 and subtract 7. And then it went up another 5. So there we go. Looks like it's going up 5 each time. So could I fill this out? So 17 plus 5 gives me 22. Has a nice easy pattern, right? It's always 2's and 7, 2's and 7. So this should be 32 and 37. And then this guy would be 47. Okay, so we found that pattern. It's adding by 5. Well, what is the rule? So remember, we always got to say, what does it start at? It's starting at 7. And what is our rule? It's adding by 5 each time. So it's important when we do recursion, right? When we're talking about recursive sequence recursion, we always state where it starts and what the rule is. And the reason is because we need to be able to, if I wanted you to, redo this sequence for me, without knowing any of the numbers, you should be able to write my sequence out. So if I just say, hey, write a sequence that's going up by 5s. You might start at 1 and go 1, 6, 11, 16, but is that the sequence that I want? No. So you have to say it starts at 7 and then it goes up by 5s. Okay, so that's why it's important to have the start and the rule for our recursive sequences. All right, let's do another one here. Find the missing value. Oh, we got some negatives. This is going to be a little bit tougher. Okay, do I know any 2 that are by each other? Okay, here's 2 of them. Well, it looks like it's going down a certain amount. So remember, I can grab any term and subtract by the 1 in front of it. So I can go negative 62 minus negative 51. Okay, so if you have a calculator, that's great. Bust that out. Otherwise, minus a negative is really adding a positive. So negative 62 plus 51 gives me negative 11. So it's going down 11 each time. So down 11, down 11, down 11. So negative 7 and a negative 11 give me what? Negative 18. So if you have a calculator, you should be able to rock this off. And there's actually a quick trick to this on your calculator if you have a graphing calculator, which I'll take a look here. So if I started at negative 7 and I'm going to minus 11 each time, I could hit enter, and you notice it gives me an answer, negative 18. Well, if I want to take my previous answer and subtract by 11, all I have to do, I don't have to type anything in. If I just hit minus 11 right away, it's going to take my last answer and subtract 11. So it gives me the negative 29. So if I just hit enter again, what's going to happen is if I hit enter, it just repeats just what I typed. So what I typed was take my last answer, which in this case is negative 29, and then subtract 11. So if I hit enter, it just repeats it. So there we go, negative 40, negative 51, negative 62. So that's another way. I could just use my calculator just like that. So I saw this guy with negative 40, negative 51, negative 62, negative 73, and negative 95. And just like before, start. Remember, our start is we're at negative 7. And what are we doing? We are subtracting 11 each time. So make sure you always put the starting value and the rule. Okay, how about here now? So if I look, let's see, it's going down 6, and then it's going up, up 12? So that's not very consistent. So is it adding or subtracting by something each time? No. If that's inconsistent, know that it's being multiplied probably. And to check, what do? We take any term, and we divide by the 1 in front. So 8 divided by negative 4. So I get negative 2. So are we multiplying by negative 2 each time? Multiply by negative 2. Yeah, this is the example I did earlier. Multiply by negative 2. Multiply by negative 2. So I just keep going. 32 times negative 2 gives me negative 64. And I can keep going all the way over here. So I should get a positive 512. And then I should get a negative 1024. So remember, you can use your calculator, or some of you could probably do some of that in your head. And same thing. What is the rule? Well, you got to state the starting value 2. And the rule, remember, you could either say like times negative 2, or you could put a dot negative 2. Okay, don't just put negative 2, because then it looks like you're subtracting 2. So put something that you know you're multiplying. All right, let's take a look. Let's actually use a situation here where we can use some recursion. So we got some toothpick figures. And in figure 1, let's describe some stuff here. So how many squares are there in figure 1? Well, there's 1 square. How about toothpicks? How many toothpicks do you see? Well, 1, 2, 3, 4 toothpicks. And the perimeter would be, well, the same thing. Remember, perimeter is the distance around. So 1, 2, 3, 4 as well. Okay, so let's go to figure 2. How many squares now? Well, we got 1, 2 squares. Toothpicks. We got 1, 2, 3, 4, 5, 6, 7 toothpicks. And the perimeter, remember, just the distance around the outside. So 1, 2, 3, 4, 5, 6. Total is 6 for the perimeter. Okay, what about figure 3? Now we have 3 squares. 1, 2, 3. Toothpicks, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And perimeter, 1, 2. And then we got 3 on top and 3 on bottom for a total of 8. Okay. Well, do we notice any patterns here? Sometimes it's helpful to write things in a table to help us see the pattern. So before we look at our patterns, let's go ahead and write this in a table here. So if you take a look, I have the figure number. Okay, so we looked at 1, 2, and 3. And then we have the number of squares, followed by the number of toothpicks, followed by the perimeter. Now it's probably a little more easier to see the pattern. Well, let's see if we could write a recursion rule for all these things. So for the figure number, our start is 1. And our rule is what? Plus 1. So let's do that for every single one. What's our start for the number of squares? Our start is 1, and our rule is plus 1. Yeah, it's going up 1 each time. How about toothpicks? Our start is 4, and we're going up 3 each time. Okay, so that one's a little bit different. And lastly, our perimeter, our start is 4, and it's going up 2 each time. All right, let's make some decisions about our pattern. See if we can make some predictions. So in figure 20, do we have a guess at how many squares there would be? Well, the figures and the squares match each other, right? So that one's kind of easy. So there should be 20 squares. That one wasn't too bad. All right. What about the number of toothpicks? Well, I could just keep adding 3 onto 10. But is there a quicker way to solve for how many toothpicks there would be? So let's think about this. Each time we go up a figure, we go up how many toothpicks? We go up 3 toothpicks, right? Well, from 3 to 20, we jumped how many figures? 17 figures. We jumped 17. So if I take 17 figures times, what does it jump? It jumps 3 each time, right? So 17 times 3, I get what? 51. So really there's 51 toothpicks being added in those 17 figures. So is that my answer, 51 toothpicks? No, because in figure 3 I already had 10 toothpicks, so I need to add these two guys together to give me a total of 61 toothpicks. So does that make sense? So we got to figure out like how many figures it jumped up and then multiply. Well, let's use that same thought process for the perimeter. Okay, so perimeter goes up 2 each time, and we jumped up 17 figures, right? So if I take 17 times 2, that's a total of 34 extra units on my perimeter, added on to the 8 that it was already at, and we're at 42 for the perimeter. Okay, so you have to think a little bit about this guy. All right, so let's go down to the next part. So number of squares is 32. So remember, it always matches the figure. And let's do the same thought process. So for number of toothpicks, see from 20 to 32, it jumped up 12 now. So remember, 12 times, it jumps 3 toothpicks each time. So that's a total of 36. And I have to add that 36 onto my 61. So I am at 97 toothpicks. Okay, so are we starting to see the pattern now? So you look at how many jump. So in this case, we jumped up 12 figures from 20 to 32, and we jump up 2 units of perimeter each time for a total of 24, and we need to add that to our last one, so we get 66. Well, what about this next one? This next one I should be able to figure out. If I look at the number of toothpicks, it went from 97 to 100. That's only a jump of 1 figure, right? Because you add 3 each time. So we just went to our very next figure, figure 33. So it's got 33 squares. And we always jump up 2 for perimeter, so that's 68. And how about this last one? This one's kind of tricky. Well, let's see. It went from 68 to 100. So how much did it jump? I could subtract those two guys. It jumped 32. So it jumped 32 units. And how many units does it jump each time? Well, it jumps 2 units each time. So if I took 32 and divided by 2, 16, what do you notice about that 16? That tells me how many figures it went up. So if it went up 16 figures, I can go back over to my figures and take that 33 and add 16 on, and now I'm at the 49th figure, which should help me solve the rest. So right here I'm at 49, and if it jumped up 16 figures, remember that's 3 toothpicks at a time. So I got to add that 48 onto my 100, so I'd get 148. So that one, it takes some thought process, right? So let's apply that to our last side. It says the heights above ground level, and this is dealing with the building. So at the 0th floor, you're at -4 height. So this is technically like the basement here. And then it looks like every time we go up 1 floor, how much height do we go up? Well, I could subtract those two. Remember, I could take 9 minus, which is really 9 plus 4. So that's 13. So it goes up 13 each time. So every time we go up a floor, we go up 13 in height. 13 in height. So let's see if we can find our missing heights and floors. Well, this first height, when the floor is 4, we just jump up 13, right? So that one's not too bad, 48. Okay, so let's think about this. So now we're jumping up 6 floors, right? And each time we jump a floor, we jump 13 in height. So I have 6 of those floors at 13 each. So we need to multiply to give us 78. So I need to add 78 onto that height, right? Because there were 6 floors and 13 each time. So that 78 needs to get added on to our 4th floor. So you got to think through it a little bit. So that would be 126. Okay, now's where it gets tough again. So we're going from 126 to 217. So I should probably figure out the difference there. So let's bring that over here. So 217 minus 126, which equals 91. Okay, so I know it goes up 91. But each floor, remember each floor, one floor, it goes up how much in height? Remember 13 in height. So what should I do with that 91? Yeah, I want to divide that by 13 to figure out how many floors that is, which in this case, it is 7 floors. So I need to go up 7 floors from the 10th floor. Okay, and then the last one is like our first one that we solved. We're going up 8 floors. And remember, when we go up 8 floors, that's 8 floors at 13 at a time, right? 13 height each floor. So I have to multiply, which gives me 104. So I have to add that 104 onto that 217 to put us at 321. So it just takes some thinking, right, to find those missing values. But just think about the patterns that are occurring. You always have to find the patterns first before you're able to fill in that missing information.